Okay, welcome back. We are now on unit rate. That is the second lesson for unit 3. So unit rate, I can explain unit rate and apply it to real-world situations. You have seen unit rate in the past. I'm going to revisit it. What is unit rate? Unit rate is a comparison. So a comparison between two quantities. Now, quantities is just a fancy word for measurements. All right. So what are some examples of unit rates? Well, we can look at speed. Speed is an example of a unit rate, and that is kilometers traveled per hour. Okay, and you know you have a unit rate when you have that slash, that division sign, because that per means we are talking about something per hour. Okay, so that slash is an indicator that you are dealing with a unit rate. All right, some others. Cost. Okay, so many dollars, so $20 per ticket. All right, it could be if you go to the store, so following along with cost. It could be $20 per kilogram. So if you're buying cheese, for example, it would be like that. Okay, so many examples out there of unit rate, and that's all we're really looking at. If you want to look at some cars, you can look at mileage. Mileage would be it's kilometers per 100 liters. Oops, kilometers per liter. Sorry. All right, so it's a mileage thing. You've probably heard the American systems, miles per gallon. Okay, so those are unit rates. So all we're doing is we're reviewing and practicing those skills here. Okay, so determine the unit rate. So Lindsay bought 8 tickets and it cost her $125. So there are 2 unit rates that come from this. So it really comes down to which one you really want to find out. So for example, I could look at it in terms of method 1, tickets per cost. And if that was the case, I would do 8 over 125. And I would get, you want to divide 8 over 125. So you get 0.064. So 0.064 tickets per dollar. Now that one really doesn't make a whole lot of sense, okay? So sometimes you're going to find you can run it both ways. Here's a prime example where that makes absolutely no sense. So you know that if you calculate this out and you ask yourself, so you need to reflect, okay, does 0.064 tickets per dollar really help me out here? Okay, 9 times out of 10 you want cost on top. You want dollars per ticket. Okay, so you can't go wrong with putting money on top. So if that's the case, 125 over 8 then, if we were to go ahead and do that calculation, so 125 divided by 8, we get 15.63. So that would be $15.63 per ticket. Okay, now they're both correct. This is correct. This is correct in terms of unit rate. One means more than the other. Okay, 9 times out of 10, people who are asking how much are tickets, this is the answer you want. Okay, you're never going to have someone run up to you and say, "Oh, there's quite a deal. You can get 0.064 tickets per dollar." Hey, no, it doesn't work that way. So, not mathematically incorrect, but it doesn't make a whole lot of sense. Here's a capacity or volume question. So a barrel filled with 300 gallons of water in 15 minutes. So again, you can run it both ways, and then you'll know if the answer makes sense. You can ask yourself, would this make sense if I was doing it? So let's do gallons per minute. We'll start with that to see if that makes sense. So that means we're going to have the gallons on top, divided by time. So 300 divided by the 15. Comes out to be an even 20, so 20 gallons per minute. So mathematically it's correct. Does it make sense? If someone asked you how fast was the barrel filling, oh, 20 gallons a minute. Yeah, that makes absolute sense. That would tell me that every minute I would have another 20 gallons. What happens if we ran it the other way? So minutes per gallon. So the minutes would now be on top, gallons on the bottom. calculate that out. So you'd have 0.05 minutes per gallon. So how fast is the barrel filling? In 0.05 minutes per gallon. A little bit backwards maybe, but it's still actually pretty valid. It tells you that every 0.05 minutes, you're going to have a gallon. So 0.05 minutes times 60 to get that into seconds. So that's the same as saying 3 seconds per gallon. So probably the first one's more common. It would make more sense if you're being told the information. Both are mathematically correct. You want to pick the one that's best for describing the situation. So I'd have to go with number 1. So in this case, I would say this is the better description, and then down here I would have picked number 2 to make more sense. All right? So again, unit rate mathematically, both processes there, it doesn't matter which one you pick, they're both technically correct. So keep that in mind. You want to pick the one that makes the most sense for you, the reader, though, when you're trying to get that information. Okay, so example. The car traveled at 90 kilometers per hour. So we're answering 3 parts here, A, B, and C. So A part, how far does it travel in 1 hour? Well, if you know your speed is 90 kilometers for every hour traveled, then therefore, in 1 hour, the car traveled 90 kilometers. It's just reading the unit rate. That's all this question's doing. So we're just reading our unit rate. Unit rate. Okay. B part. How far does it travel in 3 hours and 40 minutes? Okay. First thing we have to do is we have to get rid of this 40 minutes. So this is actually a complicated question. So 3 hours, 40 minutes. So the 40 minutes, and I'll do this off to the side here, we're going to have to do some calculations. So 40 minutes is equal to, well, how many minutes are in an hour? We know there's 60. So we traveled for 40 minutes out of a possible 60. All right? Throwing that into the calculator, or you can leave it as a fraction, because some will be reducing that and saying that's 2/3, and you'd be correct. Or you can go 0.67, and I'm pretty happy with that. All right. So that is the conversion from minutes to hours. All right, and I'm gonna make a bit of a note bubble here for you, just in case you have to look back and figure that out. So right here, note, if you want to go from minutes to hours, you take your number of minutes and you want to divide by 60, and that will give you hours. All right? So very, very handy if you have to make that conversion. Oops, I keep grabbing the bubbles. There we go. So, that being said, so now I'm going to read you the question over here, or continue working over here. So that's 3 hours, 40 minutes. That's really equal to 3.67 hours. Okay? How far did you travel? Well, you can set this up as a ratio from your previous unit. Actually, we're going to talk about ratios maybe a little bit later on. I think actually we're going to talk about ratios a little bit later on. What we're going to use is this formula up here, and this is a formula that we are going to make sure we have on our cheat sheets, because a lot of the questions with unit rate, they do involve time and travel. And we're going to be talking about some car stuff coming up here. So D equals VT. So D is your distance. V is your speed. And T is your time. Okay, so we're going to be using that formula. So if we know 2 things, we always know 3 with the formula. Okay, so when we look at this, we have time, so we have our T variable. We know that our V, our velocity, is 90 kilometers an hour, so we have that. So that means we can find that formula then. So D equals V times T, so 90 multiplied by 3.67. And you'd know that 90 times 3.37, or sorry, 67, gives us 330 kilometers. Okay, so there's quite a bit going on in that question there. So therefore, you would travel 330 kilometers. C part. C part is how long would it take to travel 1,000 kilometers? Well, we know our velocity, so if I start with that formula, d equals vt, I know distance, it's 1,000. I know my velocity, which is 90 t. Now the question is, how do you solve this? So I want to be something, I know we haven't really done a lot of algebra, okay, and how to solve equations, but this is something that's going to come up for you in real life. So it's important that we know how to do this. So what we can do, and I know I'm going to make some math teachers cringe that are reviewing this video, and even I'm cringing at the moment, but I'm going to break down and I'm going to create the science triangle, the dreaded science triangle. This is the triangle. I always tell people that it really hurts you because it's taking away a skill, but since algebra is not part of our course, I got to give you a tool to work with. So if we go back up to the top and know that formula I was talking about, what you really want is you want this particular triangle drawn to help you out. Okay? The bar up here, that would represent division. This bar represents multiplication. So if we go back here then, if I want to find time, I go to my triangle. I know I have my d, that was the 1,000. I know I have my v, so that means that because the d and v, d's on top of v, they're separated by that bar, which means I'm going to have to do division. So my time is equal to 1,000 divided by 90, and that's going to give me the time in hours divided by 90, so 11.1 hours. Okay, so that triangle again, it works because we don't have algebra background, and that's what I need to have it so that you have a skill, because you're going to come down to, well, how long is that going to take? How do I figure that out? You now have that skill using this triangle, so very, very important. So therefore, it will take 11.1 hours to go. To go 1,000 kilometers. And just to put that in perspective, that's halfway to Florida. 1,000 kilometers would get you halfway to Florida, so probably around the Georgia border. Well, actually closer to Atlanta probably, just so you have a little perspective here. Okay, so that finishes the unit rate, so there's homework associated with that. So if you have any questions, let me know. So good luck.